Hello and welcome to helpyourmath.com. In this video, we are going to talk about percent change. Let's start with some definitions. Frequently, percentages compare how a quantity has changed over time. This comparison uses two types of change, the absolute change and the relative change. The reference value, or the base, is the original given amount. So that would be, if we are talking time, it would be the earlier year. Otherwise, it should be indicated which one should be used as the base, or there should be some way of determining which one the base would be. The comparison value is the new amount. An absolute change, this is where we would subtract the new amount, the comparison value, by the original amount, the reference value. And the units are the same as the given quantities. So if we're comparing dollars to dollars, then the absolute change would also be expressed in dollars. If we're talking people to people, the absolute change would be in terms of people. This change can be positive, negative, or zero, depending on whether the comparison value is larger than, smaller than, or the same as the reference value. The relative change, to calculate this, we need to know what the absolute change is. We would divide the absolute change by the reference value. Here, we're going to convert to a percent, so we would divide and then we would multiply by 100% to put the relative change in as a percentage. Just like the absolute change, and it will maintain the same sign. So if the absolute change is positive, so is the relative change. If the absolute change is negative, so is the relative change. If there is no change, there's no change no matter what. The changes will be negative if the comparison value is less than the reference value. The changes will be positive if the comparison value is greater than the reference value. And it would be zero if they're the same. Okay, so let's talk my favorite thing, my dream house. So my dream house, it sold in 2016 for $1,299,000. It was then sold again in 2021, so 5 years later it was on the market for $1,776,000. What is the absolute change and the relative change in price for this house? To start, we're going to look at the absolute change, and we already can know that they're both going to be positive because it increased over time, right? So the absolute change, we take the comparison value, what it sold for in 2021, $1,776,000, and subtract it by the base or the reference value, $1,299,000. When I subtract, I'm going to try to do this in my head. Good luck to me. There's a bunch of nines there. Great. It's going to end in 0, 0, 0. And then let's see, we have 6 minus 9. That's not going to work. 16 minus 9 is 7. Then we have another 6 minus 9. That's not going to work. We're going to have another 7. Then we're going to have 16, right? Because then 7 is going to go bye-bye. 16 minus 12 is 4. So the house increased by $477,000 in a span of 5 years. I, of course, did this in my head. You should absolutely use a calculator if you feel more comfortable or if you don't trust my calculation, which is totally fair. I'll check it when I do the relative change because I'm not going to do that in my head. Okay, then we want to calculate the relative change. So it's nice that this person made almost $500,000 in 5 years. That's fantastic. For the relative change, we're going to take the absolute change, $477,000, and divide it by the base, the original amount, $1,299,000. And we convert this to a percent, so we're going to multiply by 100%. When we're typing this in a calculator, we do the fraction by doing the division sign. Let's pull up our calculator and see what we get. Okay, first thing, I just want to check my work. So I'm going to do 1,776,000 minus 1,299,000. And I get 477,000. What? Now we're going to take that 477,000 and we're going to divide it by 1,299,000. And one thing we could have done, I chose not to just because I was checking my work, is we could not include the 3 zeros, right? Because they both have zeros in the ones, tens, and hundreds. We could divide them both by 1,000. But because I'm using a calculator, I'm fine using it and I can see and I can make sure I have the correct number of zeros. But that is something to be careful of. Okay, so there's the original division. And now I want to convert it to a percent. So I'm going to multiply by 100%. And I get 36.72. It doesn't tell me how to round. I'll round to the nearest hundredth, 36.72. And since I'm rounding, I'm going to use the squiggly equal sign, is approximately 36.72%. So not a bad day. You made about a third more than what you paid for in 2016. and it's still my dream house to this day. It's so beautiful. Okay. Something else that happens is when you buy a car and it's, within a couple years old and it's not vintage, it loses its value. So let's look at the percent decrease here. We know it's a decrease, right? Because it went from $10,200 to $8,500. The absolute change will be $8,500. That's the new minus $10,200, the original. And when we subtract, it's going to be a negative. Oh gosh, why am I doing this in my head again? And let's see, that would be 12, that would be a 7, and that's going to be a 1. So it decreased $1,700, right? We keep the units the same, just like we did in the first example for absolute change. Then for relative change, we take the absolute change, divide it by the original. So it doesn't matter which one's bigger or smaller, we always do the original. And you can keep the negative, it doesn't matter. We know it's going to be negative because it decreased in value. 1,700 over 10,200. We're going to convert this to a percent. I like the percent. It's easier for me to interpret. It's easier for most of us to interpret. Let's see what happens when we pull up the calculator. When I do my calculation, When I do my calculation, it's going to naturally carry the negative over. I'm just going to leave it and work with that. So I have 8,500 minus 10,200, which hopefully gives me what I said, negative 1,700. We're going to take that absolute change and divide it by 10,200. That's going to be the decimal, and then I'm going to multiply by 100% to convert it to a percent, and we get 16.67. This is approximately a decrease. So we could either say 16.67% decrease, or you can say negative 16.7% change. We usually will use the word decrease just to indicate that it did drop in value. All right. Up next, in the news, you hear tuition is expected to increase by 7% next year. If tuition this year is $2,400 per semester, then what should you expect to pay in tuition next fall? Well, we're going to take... So this time we're given the percent increase, right? In the last examples, we had to figure out what it was. Now we know the percent increase. So we're going to kind of work backwards here. Percent increase is 7%. There's two ways to calculate the relative change. We can either use the same formula that we've been using, where it's the absolute change. However, we don't know what the absolute change is, so I'm just going to use A for absolute change over the base, which is 2,400, or the reference value. And we know that this, when we multiply by 100%, will equal 7%. So we can solve this little calculation, this little algebraic equation. Let's see, if we divide both sides by 100% just to get rid of the percents, we would have just A over 2,400 equals, and that would be 0.07, right? Because this would cancel out. And then this would move the decimal 2 places to the left. We do want to be careful with single-digit percents. A very common mistake is to just get that decimal and be done with it, but you have to divide by 100. You have to move it 2 places to the left. So just be aware of that potential pitfall. And then we want to get A by itself. It's being divided by 2,400. Well, I can fix that. I can multiply both sides by 2,400. And this is right here the other way. So because we knew we wanted to figure out what 7% of 2,400 was, we could have just gone straight to this step. But I just like to show how it relates to what we've already done in this video, just because everything does relate, and I think that's really important to understand. So let's see, to get rid of this, I'm going to try to do this without the calculator again. I'm going to move that over 2 to the right, so I'm going to move this 2 to the left, and then it's just 7 times 24. 7 times 25 would be 175, so this must be 168. And that would be the absolute change. So what this means is that tuition will increase by $168. So then to figure out what will the tuition be per semester, we would take we're going to kind of go in reverse order here, right? Because the absolute change, we may recall, is when we take the comparison and subtract it by the reference. Well, we already know the absolute change is $168, and we don't know the comparison, that's what we're trying to figure out, but we know the reference is 2,400. To get that comparison by itself, we would add 2,400 to both sides. And again, this might be a little extra complicated, so I apologize for that. I'm just trying to show how everything relates. So you don't have to do it this complicated way. You can just say, I know it's going to increase by $168. Therefore, I need to add 168 to 2,400. Boom, perfect, you're done. Okay, so yikes. So next semester, we're expecting the tuition to be $2,568 per semester. Boom, there it is. All right, last year, gas cost $2.50 per gallon. The good news about this example is I feel like this just stands the test of time. Every year last year, the cost of gas was $2.50. Every year, the current price of gas is $5 per gallon. It's always how it is. What is the absolute and relative change in the cost of gas? All right, so this one's another straightforward one, unlike that last example. Our absolute change, we take the comparison, the current, subtract the old, and we have an absolute change of $2.50. This is a positive, right? So it's a $2.50 increase. Then to calculate the relative change, we are going to take that absolute change, $2.50, divide it by last year's cost, multiply by 100%. I don't even need a calculator for this. I took a value, I divided it by itself. That's 1. 1 times 100%, the relative change, it's a 100% increase. So this can be weird. You might need to take a minute to think about why it's 100%, and it's because it doubled, right? It's the original cost plus the original cost again, which would be a 100% increase. Okay, this one is a double whammy of a question. The average sales price of a house in the U.S. went from $301,000 in 2008 to $152,000 in 2013 to $440,000 in 2022. We want to find the absolute and relative changes from both 2008 to 2013, and then again from 2013 to 2022. So we'll start with 2008 to 2013. And I haven't said this in a while, but I always encourage, if you've seen enough of my videos, you know I'm going to say, pause the video and see how you do on your own before I go over it. All right, hopefully you took advantage of that. Let's see what you came up with. Let's compare. All right, so 2008 was the 301,000. Because all of these are in terms of thousands and I don't have any ones, tens, or hundreds, I'm just going to call it 301K and 152K. I don't need to keep writing those zeros over and over and over again. When I'm calculating the absolute change, I'm going to take that new value. Whoops, it decreased, didn't it? Remember there was that big, maybe you don't remember, I don't know. There's a big market crash in 2008. So we have 152,000 minus 301,000, and that's going to give us negative 149,000. Yikes. So that's going to be, I will write it when I'm writing my final answer, I should say, it's negative 149,000. So a huge decrease from 2008 to 2013. That's the absolute change. Let's look at the relative change. The relative change, we're going to take that absolute change of negative 149,000 and we're going to divide it by the original 301,000. And just because since I am showing that I'm deleting all those zeros, I'm going to do it again. I'm going to use just negative 149 over 301, and they're both, K stands for 1,000. The other thing is, the reason the relative change doesn't include the dollar sign is because the dollar sign is present in both the numerator and denominator. They actually cancel each other out. We will have a unit of percent because I'm going to multiply by 100%. Let's see what happens when we do this calculation. Hopefully I'll be able to see my final answer here. Let's see, we're going to do 152 minus 301, and we get negative 149. Okay, so that's good. I did that calculation right. Then we're going to divide 149 by 301, and we're going to multiply this by 100%, and we can see the market decreased by almost 50%. That is crazy. 49.5%. Relative change was minus 49.5%. Wow, that's a big relative change. I don't know why I wrote it so far away from relative change, but the relative change was negative 49.5%. Okay, so then we started recovering, the economy started recovering, and then we had a global pandemic. And what did that do? That drove the values of homes skyrocketing without stopping. So let's see what happened here when we look at 2013 to 2022. In 2013, we had price values of 152, and then they became 440,000. Oh dear, this is going to get messy. To calculate the absolute change, we will take the comparison value, the 2022 home value, $440,000, and subtract it by that $152,000 from 2013. And when we subtract, we're going to get, that's going to end in 8, that's 43 minus 15 is 288, a $288,000 dollar increase. Wow. So that's already more than what the houses cost, the average house cost in 2013. Jumps up to 288,000. It jumped up by 288,000 to 440,000 in 2022. Okay, and now for the relative change, we're going to take that absolute change, 288,000. This is a positive, right? It increased, so maybe I say increase. Even if it's obvious, it's still good to acknowledge its existence, that it went up. It'd be really tough for it to have gone down by $288,000 over the original $152,000. And again, I'll divide by 1,000 in both the numerator and denominator. I'm going to convert this, the dollar signs cancel, and I'll convert this to a percent by multiplying by 100%. So far, so good with all my calculations. Let's see if I can finish strong here. I think there's one more example after this. Let's see. And we get 288. Okay, good. So it's $288,000 was that absolute increase. Then the relative increase will be 288,000 divided by 152,000. That's the decimal. It's already bigger than 1. That's how much this increase was. We're going to multiply by 100. And it increased by 189.5%. 189.5%. Absolutely bananas. And speaking of things going up and down, in our last example, we have Sally. Sally's company had a tough year, and they need to temporarily cut salaries by 10%. But they assure everyone in 6 months, the employer will give all employees a 10% pay increase. In 6 months and 1 day, will Sally be making the same amount of money as she is now? Why or why not? So what do you think? Is she going to be making the same amount of money? If you said no, you were correct. And why isn't it? Because isn't that just minus 10% and plus 10%? Well, no, because 10% was of some salary that was bigger than the one in the future, that 10% increase later. And we can test this out. We can do a really nice number to test this out on. Let's say Sally makes $100,000 a year. And this will be true for any number. I'm just trying to pick one that's kind of nice to work with. If she has her salary cut by 10%, then that means, so a 10% cut means that she'll be earning 90% of her current salary for those 6 months. And so then what we would want to know is, well, what is 90%? We're going to convert that to 0.9 times 100,000. I made that classical mistake, didn't I? Oh, no, I was right, because it wasn't 9%, it was 90%. Woo, I thought I missed the decimal. No. Okay. And 90% of 100,000 is 90,000. So for 6 months, she's going to be making $90,000. Then in 6 months and 1 day, when the company undoubtedly figured out all their financial woes, as we know companies are so good at doing, she's going to be making now 10% more than her current salary. So it's a 10% increase on the 90,000. And, you know, I did the original one. I think in the last video you saw, you could either do the 10% and then subtract it, or you could figure out the percent that she's earning and then multiply. We could do that here too. A 10% increase on 90,000, you can do that. Then that's going to tell you how much she'll then be making, or the amount her salary will increase, excuse me. Or you can say, well, if it's 10% increase of her 100% salary, because she's making 100% of what she's making, then her new salary will be 110% of her current salary. So either way, it doesn't matter. And if you need to watch that video, it's the most recent video if you're in my course and watching these videos in order. 110%, if we move the decimal to convert it to a decimal, is 1.1 times 90,000. And that's going to get us 99,000. Which, you might be like, well, if it's for the sake of the company, it's not a big deal. But it kind of is, right? Because ultimately, she's still taking a pay cut for no fault of her own, which, is kind of weak sauce. So will she be making the same amount of money? No, she won't. And the reason I explained earlier is because the bases were different. Originally, the base was 100,000, but within that 6 months, her salary went down to 90,000, and that was the base that we were using for the second part of this question. These have been examples on percent change. Thank you for stopping by.